Hi everyone, today we're going to talk about solving polynomial inequalities. It's pretty straightforward, but we'll go through the steps of how to do it. The great thing about this is that it doesn't matter what type of polynomial you have or rational inequality you have. The procedure is basically the same for all of them. So we'll start with something pretty straightforward, pretty basic, and these are things that you've done before when you're solving a quadratic inequality. So for example, if you had x squared minus 8x minus 20 is less than 0. Okay, so the first thing you're going to do is set it equal to 0 to find the boundary points. Excuse me. Some people refer to them as your critical numbers. It doesn't really matter too much what you call them, but the idea is this. We're going to set this equal to 0 and we're going to factor it and solve it. Now, if for some reason it's not factorable, then you'd have to use the quadratic formula, which means you would just end up with radicals. So you'd have decimal approximations of those values, which is totally fine too, but the process is still the same. When we factor this, we end up with x minus 10 and x plus 2. And so when I solve these, I get x equals 10 and x equals negative 2. And so if I were to put that on a number line, my beautiful straight number line, not to get overly fancy or anything, I'm just going to put those values on my number line. And then all I'm going to do is test values in each of the 3 different intervals I have. And I'm going to test them back in the original function. If they make, or the original inequality, if they make that inequality true, then everything in that interval will be true, and that will be part of the solution set. If it's not true, then nothing in that interval is true, so it's not part of the solution set. So here's the idea. If I were to go ahead and test negative 3, for example, so I'd have negative 3 squared minus 8 times negative 3 minus 20. That would give me 9 plus 24 minus 20. Now, it doesn't really matter what the number is. I just want to know if it's positive or negative because I'm looking to see if it's less than or greater than 0. This does come out to be positive. If you went ahead and checked 0, right, you'd plug 0 in here, you would get a negative number. And if you went and tested a number up here like 11 or something, you would also get a positive number. And so the only place where this inequality is true is between negative 2 and 10. So that's going to be my solution set. Now, because this is strictly less than, I can't include them as part of my solution. So graphically, when I write this, I would put parentheses here. This is a parenthesis, and this is a parenthesis. And I would color in the line between them, and I would say my answer then is from negative 2 to 10. Okay, so that's pretty straightforward. The same holds true if you had a greater than. You would just go ahead and find those critical numbers or those boundary points and test and see which intervals that it would work in. Okay, let's go ahead and try a different polynomial function. Let's go ahead and try this one. We've got x cubed plus x squared is less than or equal to 4x plus 4. So in this case, I don't have everything on one side of my inequality, so I want to make sure that I move everything. So I have x cubed plus x squared minus 4x minus 4, excuse me, is less than or equal to 0. This is in fact factorable. It's factoring by grouping Group your first two terms together. You can take out x squared, and then you're left with x plus 1. Group your second two terms together. If I take out 4, I'm also left with x plus 1. Leaves me with x squared minus 4 times x plus 1. Remember, we're doing all this to get our boundary point. So this factors to x minus 2, x plus 2. And this would be x plus 1. And so our boundaries then are going to be at x equals 2, x equals negative 2, and x equals negative 1. So those are our three boundaries. So I have negative 1 here. Oops, I have negative 2 actually. Let me go negative 2, negative 1, and positive 2. Again, all I'm going to do is test a value within each of these different intervals. So if I were to test, let's try negative 3. If I went back to this right here, it doesn't matter if you test in the original or if you test in this one. Personally, I think it's easier to test in this one, and then you can just see if it's positive or negative. So for example, if I test negative 3, so if I test something in this interval, if I plug negative 3 in here, and I'm not going to go through the steps of plugging it in, you guys know how to do that at this point. But if I substitute negative 3 in for x, I actually get a negative number here. If I substitute in negative 1.5, I get a positive number here. Here I would just substitute in 0. That would give me a negative number. And over here, I'd probably substitute in 3. And if I tested that, I'd get a positive number. And so remember, we're looking for all of the values where it is actually negative, because that's where it satisfies this inequality, right? Less than or equal to 0. And so it would be anything over here and between these two values, between negative 1 and 2. Now, because it's less than or equal to, instead of using parentheses, I'm going to use a square bracket. So I'd have a square bracket here, and I'm taking everything on this side, and then I would also have, a square bracket here at negative 1, and a square bracket here at negative 2, and I'm taking everything between there. So my solution set would then be from negative infinity to negative 2, square bracket, union, square bracket, negative 1 to 2, square bracket. And that would be my solution set. So that's a quadratic inequality, a higher level, that was a third degree polynomial inequality. Let's talk about a rational inequality. It's basically the same thing, just a kind of a slight variation when you're doing this type of problem. So let's go ahead and do x plus 3. Oh, sorry, x plus 1 over x plus 3 is greater than or equal to 2. So what we want to do is express it so that one side is 0, and so basically we have everything on one side of our inequality. And this is stuff that you've done before, you just haven't done it for a while. If I subtract 2 from both sides, I end up with x plus 1 over x plus 3 minus 2 is greater than or equal to 0. And if I were to leave it like this, it's just kind of a little bit messier to do that. So what I want to do is get a common denominator. So what I'm actually going to do is I am going to multiply this side by x plus 3 over x plus 3, so I have a common denominator. Okay, and that was greater than or equal to 0. So I end up with x plus 1 over x plus 3 minus 2, I'm going to distribute, so I get minus 2x minus 6 over, actually I'll do this because I have the minus in front here, so I'll leave the plus there for a second. over x plus 3 is greater than or equal to 0. And then when I combine them into a single fraction, then I'll distribute this negative. So I end up with x plus 1 minus 2x minus 6 all over x plus 3 is greater than or equal to 0, which then gives me negative x minus 5 over x plus 3 is greater than or equal to 0. So that gives me my rational inequality. Now, to find my boundaries, so this is where it's just a little bit different. I'm going to set my numerator and my denominator equal to 0, and those are going to be my my boundaries on my number line. So if I start with my numerator, I end up with negative 5 minus x is equal to 0. So I end up with then x is equal to negative 5 when I solve that. And if I have x plus 3 is equal to 0, I end up with x is equal to negative 3. So those are going to be my two boundaries, okay? When I do that, then if let me change colors here. I'm kind of working backwards on the paper here. So here's my number line. Here's negative 5. Here's negative 3. And again, all I'm going to do is test values in these different intervals. So I would probably test negative 6 here. I would end up getting a negative number. If I plug it back, I could plug it back into here. Okay, I would plug these values back into this inequality here. I wouldn't go back to the original because that makes it a little bit harder. So go back to this one. So plug negative 6 in and you would get a negative number. If I plugged negative 4, that's between these two, I would get a positive number. And then if I plugged 0 in on this side, I'd get a negative number. Remember, I'm looking for anywhere that it comes out to be positive because it's greater than or equal to 0. Excuse me. So I'm going to be taking values in here. Now, here's where you have to be careful. I'm putting a square bracket here on this side because it's greater than or equal to 0. However, I cannot put a square bracket on this side. I have to put parentheses because of the fact, and this is where it's slightly different, because of the fact that this is your denominator. So at exactly negative 3, it makes my denominator 0 and it's undefined. So no matter what, I will never be able to include that in my solution, regardless of the fact that it says greater than or equal to here. So this is going to be my solution. If I were to write that out, I would have from negative 5 to negative 3, a square bracket on that side, and a parentheses on the other side. That's basically the idea behind it all. Hopefully that was helpful for you guys. You can go ahead and do the assignment. Have a fantastic Thanksgiving, and I'll be seeing you next week. Take care, everybody. Bye-bye.